When you look through this glass, something strange happens. You're not watching a screen. You're standing inside a space that doesn't exist. 23 million pixels, projected through layers of glass thinner than a credit card. Light bent, focused, and timed so precisely that your brain can't tell what's real anymore. Building this took Apple 7 years. Let's see how they did it. Every Vision Pro starts here. A single block of aluminum alloy. No welding, no joints. Just one continuous piece of metal carved away until only the frame remains. The CNC mill runs for 9 hours straight. 5 axes of motion, tolerances measured in microns. Because this frame has to hold everything perfectly still while your head moves through space. Then comes the glass. Not regular glass. This is curved under vacuum heat, using the same process that makes $10,000 cinema lenses. During molding, even one dust particle will ruin it. You'd see the distortion, so they scrap the whole piece and start over. The front glass isn't just a window, it's an optical element. Light has to pass through it twice, once going in, once coming back out for the outside display. Now we get to the eyes. 12 cameras, 5 sensors. All working together to do something most computers can't. Understand three-dimensional space in real time. The LiDAR scanner fires invisible dots across your room, thousands of them, measures how long each one takes to bounce back, builds a depth map accurate to the millimeter. 2 infrared cameras face down. They watch your hands, track every finger independently. You don't touch anything. You just pinch the air and the interface responds. 2 more cameras face inward, at your eyes. They track where you're looking with enough precision that you can select a button just by staring at it. Watch someone use it for the first time. That moment when they realize they're just moving their hands naturally and it works. No controllers, no learning curve, just intention becoming action. All of this, 12 video streams, depth data, hand position, eye position, processed continuously. We'll get to how in a minute. Assembly happens in a clean room. Not because of contamination, because of precision. These are the displays, micro-OLED panels. Each one smaller than a postage stamp. Each one delivering 4K resolution. That's more pixels per inch than any screen you've ever used. Robots mount them, but not just robots. Robots with laser guidance systems borrowed from semiconductor manufacturing. Because if the display is off by even a fraction of a millimeter, the whole image goes blurry. Before the frame gets sealed, a human checks it. A technician under a microscope at 100 times magnification. They're looking for anything: a hair, a fingerprint, a misaligned connector. One fingerprint means they pull the whole assembly and start over. Fiber optic cables connect the displays to the processor. Magnetic cushions align themselves automatically. Every part has to fit exactly right because this device sits on someone's face for hours. Inside the frame sit 2 processors. Most headsets have 1. This has 2, and they do completely different jobs. The M2 runs everything you see: your apps, your windows, video, games. All the computing you'd expect from a Mac. The R1 does something harder. It takes the feed from 12 cameras and 5 sensors and makes sense of it in 12 milliseconds. 12 milliseconds. That's faster than a blink. Actually faster than your brain can detect delay, which is why when you move your head, the image moves with you perfectly. No lag, no swimming sensation, no nausea. Other headsets process sensor data through the main chip. That takes longer, 30–40 milliseconds. Long enough that your brain notices something's wrong. Both chips generate heat. So, Apple built the thinnest fan system they've ever made. You can't hear it, but it's pulling air through channels machined into the aluminum frame. The battery pack sits outside, connected by a braided cable, not wireless, too much latency. Not inside, too much weight. This way, the headset itself weighs less than a pound. Here's the strange part. The front of the headset has a screen facing outward, not a camera feed. A rendered version of your eyes. When you first put it on, it scans your face, builds what Apple calls a persona. A digital version of you. And when someone walks up while you're wearing it, your persona makes eye contact with them. It's not perfect. It looks a little uncanny, but it solves a real problem. How do you stay human when you're wearing a computer on your face? The outside display also shows something else. A glow. Different colors for different modes. Blue when you're in an app. Rainbow shimmer when you're fully immersed and can't see the real world. Little signals. Visual language. So people around you know if you can see them or not. After assembly comes testing. Every unit goes through the same sequence. Dropped from measured heights, temperature cycled. Sensors calibrated against known references. Then it gets marked. A serial number, etched by laser into the aluminum, packaged, and shipped. What arrives is a device that turns your room into a canvas. Puts windows wherever you look. Lets you work in a space that only you can see. Light, motion, sound, depth, all woven together into something that feels like it's actually there. From molten glass to digital space, from aluminum blocks to rooms that don't exist. 7 years, 12 cameras, 23 million pixels. This is how the future is made.